Hi, we are going to review some pharmacy calculations. I'm going to assume that you already have some basic math skills like adding, subtracting, multiplying, dividing fractions. If you're having trouble with those, then get with me and we will work out a plan to get you where you need to be. First, some test-taking tips. So first of all, you have to memorize quite a few conversion formulas. I will point those out as we go through this PowerPoint. Please have your blank note cards ready to fill out, and that way you have something that you can use to study from. When you read word problems, you have to read the problem carefully because usually figuring out what they're asking you is the most difficult part. The math generally is fairly easy. Some more test-taking tips. We're going to develop some consistent approaches to different kinds of calculation problems. The other thing that I suggest you do is when you look at the answers, you look at them for reasonability, so you eliminate any answers that are out of the range of possibility. I also suggest that you do the calculations before you look at their choices of answers, and that way you pick the answer that fits your answer. And then you're always going to use your units, and you make sure that the unit of measurement in your answer is what they're asking for in the question. So first unit that I want to talk about is grains. It's from an old apothecary system. That system isn't used very much except for this one unit of measure. A grain was about the size of a rice grain. 65 milligrams is the conversion that we usually use. It might be used for thyroid medications, acetaminophen, morphine, and phenobarb. More commonly used conversions, these I sometimes referred to as clever definitions of 1, because if you use this as a conversion factor, it's just like multiplying by 1. So you haven't really changed anything. So you can convert units to the unit that you want by using these conversions. And these are conversions that you should memorize. So get out your note cards. First one is 1 teaspoonful is 5 mLs. A tablespoonful is 15 mLs. A fluid ounce is 30 mLs. Cup is 240, and a pint is about 480 mLs. The weight conversions that I think you should memorize: 1 grain is 65 milligrams, 1 ounce is 30 grams, 1 pound is 16 ounces, and there are 2.2 pounds in a kilo. Again, when you're using dosage calculations, always use those units. And then we'll set up the calculations. I suggest you always use paper and pencil to confirm those calculations are set up appropriately. So here's a sample calculation, and in this question it asks you to convert 4 pounds 12 ounces to kilograms. So the conversion that you need to know to do this is 1 pound is 16 ounces. So I'm going to set up that 12 ounces because that's the part that's kind of giving me trouble right now. 12 ounces times 1 pound over 16 ounces is 0.75 pounds. So 4 pounds 12 ounces is the same as 4.75 pounds. So I have 4.75 pounds times 1 kilo over 2.2 pounds. I have pounds in my numerator and pounds in my denominator, so I can get rid of that. So 4.75 pounds is equal to 2.159 kilograms. I'm going to round that to 2.2 kilos. So just to make sure you know how to do this, I'd like you to convert 45 pounds into kilograms. So 45 pounds times 1 kilo over 2.2 pounds. I have pounds in my numerator, pounds in my denominator, so they cancel out. So 45 pounds is equal to about 20 kilograms. So in the metric system, generally we multiply or divide by 1,000 to get from different units to other units. So micrograms multiplied by 1,000 to milligrams, multiplied by 1,000 to grams, multiplied by 1,000 to kilograms. In the metric system, generally we're moving decimal points by 3 places. So for example, to go from grams to milligrams, I would multiply that by 1,000. or move the decimal point to the right by 3 places. So 3.56 grams is equal to 3,560 milligrams. If I want to go the other way, from milliliters to liters, I'm going to move the decimal point left 3 places, or multiply by 0.001. So 238 mLs is equal to 0.238 liters. So checkpoint, how many milligrams are in a gram? And that would be C, or 1,000. In pharmacy, you'll need to be able to convert times to military time. So here's an example. At midnight is 100, 6 a.m. is 600, noon is 1200, 1 p.m. is 1300, and 11:59 p.m. would be 2359. So another way to depict that is if you know typical time, 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, as it goes around. But then when you get to 1 o'clock p.m., you're going to have to add 12 hours. So 1,300 hours, 1,400 hours, and as it goes around. Roman numerals. You'll need to memorize these, especially one is just I, V is 5, X is 10, L is 50, C is 100, D is 500, and M is 1,000. And some rules for Roman numerals: if a numeral is repeated, then its value is repeated. So if you see XXX, that would be the same as 30. You can't repeat a numeral more than 3 times. 5, 50, and 500 are never repeated, and they're never subtracted. If a smaller number is placed before a larger number, then that number is subtracted from that larger number. And when a smaller number is placed after a larger numeral, it's added to the larger number. Temperature conversions. A common test question: what's a typical freezer temperature in Fahrenheit or Celsius? So freezer temperature -26 to 0 in Celsius, -15 to 32 in Fahrenheit. Refrigerator temperatures 2 to 7 degrees Celsius, or 36 to 45 Fahrenheit. And room temperature is basically considered 15 to 30 Celsius, 59 to 86 Fahrenheit. And the conversion is Fahrenheit equals about 2 times Celsius plus 32. Examples of ratio and proportion. We're going to do quite a few of these because I would expect that you would see them on your pharmacy exam. So the next question: what volume of 100 milligram per ml injectable should be drawn to prepare a 120 milligram dose? So go ahead and set that up. This is how I set it up. 100 milligrams per 1 ml is equal to 120 milligrams per X. So I'm going to multiply 120 times 1 divided by 100. I get X equals 12 mLs. The doctor orders amoxicillin 250 milligram suspension per dose. What you have in stock is 150 milligrams per 5, so you have to know how many mLs do you need for 1 dose. So go ahead and take a minute to set that up. The way I set it up is 150 milligrams per 5 mLs equals 250 milligrams over X. I'm trying to solve for how many mLs do I need per dose. So I'm going to multiply 250 times 5 divided by 150, and X is going to be equal to 8.3. Another ratio and proportion example. The pharmacy receives a prescription for 100 milligrams of amoxicillin to be taken 3 times a day for 10 days. What I have on hand is a 150 ml bottle of amoxicillin 125 per 5. How many milliliters of the suspension should I dispense? And what will be the patient's dosage instructions on the label. So first thing I want to do is figure out how many mLs am I going to have per dose. So I know that the dose is going to be 100 milligrams. I don't know how many mLs that is. So I'm going to set up a ratio and proportion. 100 milligrams is my dose. What the strength of this bottle, and I get that from what's written here in the word problem, 125 milligrams per 5 mLs. So it's 4 mLs per dose. So 4 mLs per dose, and then it tells me in the problem that the patient is going to take it 3 times a day. So I have 4 mLs per dose times 3 doses per day. So I have doses in my numerator, doses in my denominator. I can get rid of that. So if I take 4 times 3, it's 12 mLs per day. Then it tells me in the problem that it's a 10-day course of therapy. So I have 12 mLs per day times 10 days. It's going to be 120 mLs per course of therapy. So I'm going to dispense the whole 150 ml bottle. I have enough there. And basically what I'm going to tell the patient is give, probably a child, give the child 4 mLs 3 times a day for 10 days, and then I'll say discard remainder. That's what I would say. If the question gave you an option of 120 mLs as how much you would dispense, that would be an okay answer as well. Generally, pharmacists don't pour out the excess. We just give it to the patient and tell them to discard the remainder. Here's another ratio and proportion example. How many milligrams of this medication, furosemide, which is a diuretic, are in 6 mLs of the solution shown on this label? So I'm looking on the label and it says 20 milligrams per 2 mLs. I want to figure out how many milligrams is in 6 mLs. So I'm going to use ratio and proportion. From the label, 20 milligrams per 2 mLs, I'm going to put x over 6. I multiply. 6 times 20 is 120 divided by 2 is 60. So I have 60 milligrams per 6 mLs of solution. And that makes sense to me. Here's another ratio and proportion example. Maybe the problem says make 35 mLs of a solution containing 2 grams of salt per 7 mLs of water. So this is giving you a ratio 2 grams of salt per 7 mLs of water. And it wants you to make 35 mLs of this solution. So I'm solving for x. How many grams of salt do I need? So I multiply 2 times 35 divided by 7. So y equals 10, or 10 grams of salt. So here's one that's a little bit more complicated. A physician orders a drug to be infused at 10 micrograms per kilogram per minute. The patient weighs 70 kilograms. The total dose the patient is to receive is 21 milligrams. How long must the IV continue for the patient to receive the proper dose? So I'm solving for time. So I have to do some conversions and figure out what the time is. So the dose is 21 milligrams. I'm going to go ahead and convert that to 21 micrograms. That way I can use this 10 micrograms per kilogram per minute, is the infusion rate, times the patient weight. They weigh 70 kilograms. So I'm going to get 700 micrograms per minute. So 700 micrograms per minute. But what I need for this total infusion is 2100 micrograms. So I'm going to take 1 times 2100 divided by 700, and x equals 30 minutes. Sometimes you have a product that is a solid that is dispersed in a liquid, and those might be described as percent strength, or product that has a concentration that's weight in volume. Usually those solutions are expressed in grams per 100 ml. That's where you get the percent, per 100. So an example of D5W, or dextrose 5% solution, is 5 grams of dextrose in 100 mLs of solution. So here's a weight and volume example. How many milligrams of dextrose are in 75 mLs of D5W? And so they want you to describe the amount in grams and then convert to milligrams. So D5W, you should know this, D5W is going to be 5 grams of dextrose in 100 mLs of water. So that's going to equal 75 mLs over, and then what you're trying to solve for is X. How many grams in 75 mLs? So I'm going to cross multiply 5 times 75 divided by 100. So Y equals 3.75 grams of dextrose. So there's my grams, but then it also asked me to convert to milligrams. So see, 3.75 grams times equal to 3,750 milligrams of dextrose in 75 mLs of D5W. Sometimes drugs are calculated using body surface area. Many times you see this in pediatrics or maybe chemotherapeutics. So in this type of calculation, you would need to know a patient's weight and height. And then you'd have to have a nomogram. And here's a picture of a nomogram. So if I had weight and height, and I draw a line here where those two things intersect, that would give me the body surface area. So just to make sure you're still with me, I have a couple of questions. What's the standard unit for weight and volume solution? That's going to be grams of active ingredient over 100 mLs of solution. How many milliliters of a 250 milligram per 5 ml solution are needed to make 750 milligram dose? That would be 15. And then what's the unit of measure used in body surface area questions? And that would be meter square. In pediatrics, they might also use a weight to calculate a dosage. Oftentimes they use something called Clark's rule, and that would be the weight of child in pounds divided by 150. So that's kind of like the average adult, I guess, times the adult dose equals the child's dose. So that gives you a ratio for how much that child weighs. And I always think about Clark's rule using a Clark bar, the old candy bar, and think about weight. Another way that people have used to calculate pediatric dose is Young's rule. Young age goes by patient's age. And in here it's patient's age in years divided by the child's age plus 12 times the adult dose. It gives you the child's dose. Let's move on to dilution problems. It's common for a technician to have to dilute a stock solution to make a less concentrated solution. So typically the pharmacist will perform the calculation, but you're going to be required to double check it and make sure it's correct. So, and plus dilution questions are common on certification exams. So the dilution formula that you should recognize and remember is the initial strength times the initial volume is equal to the final strength times the final volume. So here's an example of a dilution question. You have 30 mLs of a 20% solution. How many mLs of a 10% solution can be made if sterile water is added? So what you know, you have a 20% solution, so that can be depicted as 20% or 0.2, and that initial volume is 30 mLs. Your final strength is 10% or 0.1, and so the final volume is what you're trying to figure out. So I plug it into that equation that we just talked about on the previous slide. 0.2 times 30 mLs is equal to 0.1 times x. So multiply this out and divide it by 0.1, X is equal to 60 mLs. And that makes sense because I had 30 mLs of a 20% solution. I halved the strength, so I doubled the volume. Alligation is used when you need to prepare a compound that you don't have in stock. So generally you have a compound that might be too strong and one that isn't strong enough, or maybe doesn't have any active ingredient at all, and you would combine those two to make the right percent strength. So the question says, how much 10% and 60% urea cream should be used to prepare 100 grams of 40% urea cream? So I'm going to draw a tic-tac-toe box, and I'm going to put the percent strength that I want in the center of the box. That's what I'm aiming for, 40%. And then in the top left-hand corner, I'm going to put the more concentrated strength I have available to me. And in the bottom left-hand corner, I'm going to put the percent strength that I have that's less concentrated. Now you'll notice that 40 is what I'm shooting for, 60 is greater than 40, and 10 is less than 40. The numbers have to be that way for this to work. So then I'm going to draw a diagonal line. 60 minus 40 is 20. I'm going to write that in that box. And then I'm going to do the same thing on the other side. Draw another diagonal line. The difference between 40 and 10 is 30, and I'm going to write that in the box. So what I have here is this kind of tic-tac-toe box, trying to make a 40% strength of this cream. This is telling me that I need 30 parts of the 60% and 20 parts of the 10% to make this cream. So I'm going to add these two. 30 parts plus 20 parts is equal to 50 parts total. And so if I'm looking at this 60% cream, I'm going to have 30 parts divided by 50 parts total. Put an equal sign there because that ratio is going to stay the same, because I want 100 grams of this 40% cream, and I'm going to solve for y. How do I solve for y? I cross multiply. 100 grams times 30 parts divided by 50 parts is going to equal how many grams of that 60% cream do I need? So the question might ask me, how much of the 10% cream do I need? So if I know I have 100 grams total and I'm going to use 60 grams of the 60%, then I know I'm going to need 40 grams of the 10%. So let's do another example. How much 70% alcohol must be mixed with 10% alcohol to make 480 mLs of a 50% solution? So 50% is what I'm aiming for. I'm going to put that in the middle of my tic-tac-toe box. My higher percent strength is 70. My lower is 10. 70 minus 50 is 20 parts. The difference between 50 and 10 is 40 parts. So total, I have 60 parts of this cream. So 40 divided by 60 is 2/3. 20 divided by 60 is 1/3. So I can say 2/3 of the 480 mLs is going to equal 320 mLs. 1/3 of 480 mLs is going to equal 160 mLs. Another question in pharmacy might be, how much money are we making? So percent markup be the markup divided by the selling price times 100. So a question might be, the cost of a drug to the pharmacy is $40 for a bottle of 50 tablets. The pharmacy sells that bottle for $50. And so the question could be, what is the percent markup on retail? So the markup on retail, markup was $10. So I bought it for 40, I'm selling it for 50. Divided by the selling price times 100 is 20%. Another question they could say though is, what is the percent markup on cost? So that would be, the markup is still the same, $10. But instead of using selling price, I'd use my cost, which was $40. 10 divided by 40 times 100 would be 25%. I hope that helped.